have everything quite set up the way that I wanted it to. Namely, I didn't have the auto start thing turned on. Okay, cool. It looks like Twitch is going now. Let's see if the YouTube one is going yet. And it looks like the YouTube one's going. Okay, awesome. So yes, there we go. I'm going to say what I'm doing again for the YouTube people because it wasn't working with YouTube at the start. So today I'm taking a PR from a while back that I made initially with the plan that I try and get it working in Yarn. The Yarn APIs just weren't there at the time. They might be now, but I was hanging out with a friend and we were talking about some of the Kubernetes APIs, and it's definitely there in Kubernetes, so I'm going to do it there as the starting point. Today I'm hanging out at the Domino Data Lab offices this afternoon. I had a really nice conversation with my friend Anne about one of the projects that we're working on. Later on, near the end of this month, I'll be at JupyterCon in New York. So JupyterCon New York. So if you want and you're in New York, definitely come join me there, and that'll be fun. Okay, so that being said, let's get down to brass tacks and go look up this old PR as a starting point. GitHub.com/Apache. We're going to go into Spark, not Beam this time. Okay. Still need to actually update my credit card information for GitHub, but I'll get there. And so this is going to be a really, really old PR that we're going to go dig into. Actually, let's update this PR first. It's take advantage of a known partitioner for distinct RDDs. Just if anyone has feedback on that, I want to do that really quickly. And so this is keep track of nodes / spot instances, which are going to be shut down. So you can see that the initial plan for this was very much focused on sort of cloud deployments. And that would require some amount of work integrating with each cloud. But since Kubernetes has a built-in idea of sort of container shutdowns, we can do something fun there. Cool. So take advantage of known partitioner for distinct on RDDs to avoid a shuffle. Let's double check and see if anyone has any comments here. Yeah, sure. Yeah. Okay. Yeah, okay, so sure. I'll do a micro benchmark sometime this week. Oh, you can't hear anything. Oh, cool. Thanks for the heads up on that. Let me check the sound settings here. Input is here. Oh, input's really low. Okay, sorry about that. Thanks for letting me know. Hopefully the audio is working now. And I will explain again what I'm doing, and this time hopefully people will actually hear it. So yes, the idea for today is to resurrect this old PR, keeping track of nodes or spot instances which are going to be shut down, and bring it over into Kubernetes instead of trying to do it on sort of a per cloud basis. And the idea here is that we can get an idea of if a node is going to go away, and we can do something smart there. I'm gonna go to the YouTube chat really quickly and just apologize and hopefully double check that the audio has been fixed. Oh yay, it does work. Okay, awesome. Good. Okay, so this is the PR. Once more, I'm going to say thanks to Domino for having me today. I'm hanging out their offices. The reason I brought up the Jupyter page earlier is that Anne and I were just syncing today on some stuff we're getting ready together for JupyterCon. And if you want to come, see me at JupyterCon, I'll be there. But today we're definitely going to focus on sort of Scala Spark code, and this is the part that we're going to do. Yeah, okay, a little bit more tea, and we'll be off to the races. That's some good tea. Okay. So initially, the idea here is keep track of nodes that are going to be shut down to prevent scheduling tasks. And so the idea is, since each vendor notifies instances of pending termination in a different manner, it's left to the instance to notify the workers, decommissioning with sig power. And the thing here is, that's cool and all, but it's not really great to have a thing where no one can use it initially. And so we can integrate, so I'm going to sort of refresh this PR, but we're also going to do it so that we implement it so that the Kubernetes implementation will send sig power, and then we can also have integration tests around it. I don't think we'll get to the integration tests today, but hopefully we'll be able to get something in there. Yeah. So let's go ahead and do this. And you can see this PR is really old. It's from August 24th, 2017. And it changes a lot of shit. So that being said, let's go ahead and start the refresh. Now this is old enough that, so yeah, let's go and take a look at commits. There's like a lot of commits here. And I mean, so we could literally take this PR and refresh it. That might not be the worst thing in the world. Let's go through here. So one of the things that I thought was in here that I wasn't like super sure I wanted was, I'm gonna go take a look, worker decommissioning. Yeah, okay, decommissioning worker. Skipping decommissioning worker. Yeah, okay. This looks okay. I was worried, inside of here when I was looking through it earlier, I thought, oh, okay, maybe my only changes inside of block were these two comments. And executor decommission. Oh yeah, the idea is that an executor decommission shouldn't count against the failure count for a task, because we don't want our decommissioned executors to essentially result in our tasks failing. Like, yeah, they're failed and we need to recompute, but you know, we only allow tasks to fail a certain number of times in Spark before we sort of throw up our hands. And a decommissioning is not one of the cases where we would expect that to happen. Or a decommissioning is not a case where we would want that to count against the task. So this looks pretty solid. And it looks like the code that I thought was in here isn't actually in here. So this is maybe a little bit more reasonable to just revive. I don't have to split it out into two PRs. There is a separate thing. Oh, I'm going to rename this script. I don't like it. I'm going to call that worker. Okay, let's go ahead and check out this really ancient code, merge in master, and start getting it working on Kubernetes. Cool. Git merge master. Yeehaw. Okay, let's take a look at our differences. So remove executor is not very happy with me. We will remove this. Oh, I mean, that's fine. And actually, yeah, so this merge is pretty simple, I think. Let's go look at course grain scheduler. Oh yeah, this is some other stuff. Spark, course grained scheduler backend.scala inside of cluster. Okay. All right. So we had remove executor as a separate Let's go take a look. Remove executor. Oh. Oh, okay. I'm confused. Remove executor. Okay, so we just have 2 instances of those? Yeah. Okay. That looks good, but let's go move this next to remove executor. I think this would be where it belongs. Who knows, though? I mean, this is just kind of doing a merge by dead reckoning. Okay, how's this look? Yeah. Okay, cool. Get commit dash am. Merge in master. So that being said, I really want to look at the diff between us and master and see if it makes sense. Okay, so we add a new deployment message, worker decommissioning, case object decommission self, mark self for decommissioning. We add another state to our executors. They can be launching, running, killed, failed, lost, exited, or decommissioning. Sure. The standalone app client. If state is decommissioning, yeah, sure. That looks reasonable. We don't count failures from decommissioned workers since they're expected. That makes sense. And we have a private decommission worker function. Decommission worker. So decommissioning a worker decommissions its executors. That makes sense. And we remove the workers from the persistence engine. On recovery, do not add a decommissioned executor. That makes sense. We wouldn't want to add it back in. If worker decommissioning is enabled, we register SIG power handler and we connect decommission self. If decommissioned, we don't launch executors at the worker level. That makes sense. Not super sure why that changed. This change looks pretty unrelated. I think I'll back it out. Let's go find this, because there's enough other changes going on. Worker.scala. And it is case sum master graph. Cool. Okay. Yep, that looks reasonable. Worker decommissioning. The block hit, not block hit thing is kind of unrelated, but it's also just case left, case right isn't like super clear. You know what's going on. And I found that useful in my downstream work. Yeah. Oh, the indentation changed here. Let's go check that. Course grain scheduler backend. This is like doing essentially a code review on my own code to try and get it back up to date. Executors pending to remove dot. And def executor is alive. Okay, def executor is alive. I mean, this is what the Emacs indentation wants to be. Whatever, it's probably fine. Yeah, okay. This looks reasonable-ish. Let's start compiling it. I think I have one of, okay, cool. Yeah, this is my compilation here. So we're going to go ahead and compile it and test compile it. And while that's happening, we're going to go and start poking inside of the Kubernetes bit so that we can start trying to make this happy with Kubernetes. So it's going to be up here. It's like resource managers, Kubernetes. So there's a Spark Docker file. We're also going to want to copy some things here as well. So entry point.sh into opt, and we're going to copy a shutdown script. Or actually, the shutdown script is probably already copied into bin, I think. Let's take a look. Oh, cool. Okay, well, let's fix that part first. Oh, there's no context here. Oh, decommission executor and remove executor no longer. So this is just receive and reply. Yeah, I think it's better to reply. But yeah, let's go put this back under remove order. Okay. Cool. Okay, let's go get diff master, and there should be like a shell script. So let's go find our shell script. So it's decommission. What's in sbin? Start master, start slave. Ugh. Okay, fine. I guess we'll keep that name. Although, whatever. I mean, it's my PR. Okay, so that's fine, I guess. Spark worker instance is not defined. Instances. What the hell is the shell script doing? Which is normally a great sign that I know what's going on. Let's go look at the git log on my own shell script. Cool, one commit back from when I worked at IBM. Okay. Is this the same thing as the logic used inside of stopslave.sh? Yeah, okay. I mean, it's the same logic, so whatever. We'll assume it works for now. And then we'll make an integration test and see if it doesn't. Because the Kubernetes stuff probably isn't actually depending on calling stopslave. But that's okay. Let's do this. More coffee. I wish I had coffee. Okay. So the sbin stuff is already copied over, so we don't have to change the Docker file, so that's great. So that's cool. So, this is Python stuff. No, we're not Don't have to go there. Okay. So let's go on. Ooh, the integration test exists. Yay! But okay, for now, let's just do core src main Scala. Or what's inside of resources? No, it's min-env. Scala or Spark. Is it going to be okay? Kubernetes driver spec. Kubernetes volume spec. Spark pod.scala. Okay, so there's a container builder. Okay. That creates the driver conf. I want to go look at the worker conf. Okay, here we go. Here's our executor conf. So that's our party. Okay. Kubernetes conf. What's inside of our thing called? No, it's just. Spark conf, role specification, role labels, role annotations, role ends, Spark files. Okay, whatevs. Let's go find Kubernetes. It's like container shutdown notification. Cool. So by default, sigterm is sent to the main process with PID1. I think I can configure this though. Can I change who gets sent this signal? Or can I change? Okay, so that changes the grace period. There we go. Yeah. Yes. We can add a pre-stop hook. So let's go find this pre-stop hook. Okay. Kubernetes pre-stop. Okay. Okay. Hook delivery will be guaranteed once. Okay. So now that's post start. Let's go look at termination of pods documentation. If the pre-stop hook is running after the grace period expired, with a small second extended grace period, and then the process and the pods are sent the term signal. So what we're going to do is we're going to write a pre-stop hook, which just sends the signal and then just blocks until the driver is gone. And for now, triggering the pre-stop hook, sorry, not driver is gone, until the JVM is gone. For now, triggering the pre-stop hook doesn't actually kill anything, it just stops us from accepting new jobs. So it'll wait essentially the termination timeout without accepting any new jobs. And like a good follow-up to this would be to, once there are no jobs, to actually exit if we're in a decommissioning state, but we don't have to do that right away. I want to do the simplest thing first and the smarter thing second, because the less work I have to do, the easier my life is. Okay. So that being said, let's go see how we specify the pre-stop hook. Okay. Container hooks. Okay. Container lifecycle hooks. Okay. This is the one. Image pull policy. Node selector. Get option. Okay. So this is create driver conf, which returns a Kubernetes conf, a Kubernetes driver specific conf. Okay, and this is a Kubernetes conf of no templated type. Kubernetes executor specific conf. Okay. And so then inside of Kubernetes conf, role labels, role annotations. So where do I specify Kubernetes pre-stop. Yeah, this is the one where, okay, so it's inside of Spec. Oh, actually we specify it here, yeah, okay, you can customize the grace period. Oh wait, this doesn't show pre-stop. Okay. Spec, lifecycle, pre-stop, exec. Okay, so we only want to set this under specific circumstances though, namely if decommissioning is actually enabled. So there's presumably a part where this Kubernetes conf gets turned into something useful. Maybe it's inside of sparkpod.scala. No, it's not useful. And no, it doesn't look like it. Okay, this is just all of the Kubernetes specific configuration files, constant features, basic driver feature setup. Kubernetes feature config step. Okay. Wait, edit spec. Fuck it. Let's go grepping. Edit spec. Resource managers, Kubernetes. Okay. Is inside of Kubernetes client application. Let's go take a look at that part. Okay, Kubernetes client application. Okay. Edit spec. Okay. So that's the driver pod. And so this goes and adds containers. Resolve driver container, add new volume, spark volume with new config mapping, with name and config map and volume and spec build. Okay. But man volume feature step. Local over feature step. Okay, well. Where is this config actually getting turned into something useful? Get additional Kubernetes. Okay. Return any additional Kubernetes resources which should be added to support this feature. Only applicable when creating the driver and cluster mod. Okay. Kubernetes client application uses the Kubernetes conf. Okay. But let's go. Kubernetes conf. Kubernetes conf. That's the driver spec. Create driver conf. So if we go Kubernetes conf.scala, there's a create Is it, okay, executor conf. Let's go look and see where people, what we do with the executor conf. Create executor conf. Okay, so Kubernetes conf, executor pod allocator. Okay, that's the one that I want. Executor pod pods allocator dot Scala. Okay. Conf. Okay. Okay. That gives us a Kubernetes conf. Let's go find executor conf. What do we do with this? Okay, executor builder, build from features. Okay. Executor builder is Kubernetes executor builder. Okay, let's go find Kubernetes executor builder.scala. Okay. Build from features. Okay, base features, secret feature, secret M feature, volumes feature. So base features is sequence of provides basic step, provide local dir step, and secret feature, secret M feature, volume feature. I'm not sure if this should get a new entry here or not. What? Okay, well, let's go look at provide basic step. Let's see what's inside of provide basic step. Basic feature step. New basic feature step. Okay. Basic feature. God damn it. Okay. Basic feature step comes from features. Let's look inside of basic basic executor feature step. Okay. So yeah, this is the place. Yeah, this is probably the place where it should go, I think. I think this would be basic. I don't know. Well, we can start here and we can go from there. So executor container is container pod with name executor, with image policy. These are the new resources. And that's the ports and 2 R's. So, except, let's go look at what's inside of mount secret feature step. Mount secret feature step. So, pod, Spark pod, Kubernetes conf. Edit or new spec. Well, I mean, I don't know if I want to put this in a new step or if I want to put this in the base step. I really don't know this code well enough. I feel like maybe the base step is okay unless someone tells me no. And to be fair, if no one tells me no, let's maybe, well, okay, I agree it can fit within the basic step if it's a single edit spec. If it's more developed, it should probably belong as a separate feature. If it's a step shared by the driver and executor. Yeah, no, I think we would only ever do decommissioning on the executor. And this is the basic executor feature step, and so it's not a thing that we'd want to, so it's not going to be shared, so I think it's okay. Yeah, and we can put it in here now, and I can make the PR, and we can get more feedback, and we can go from there. So let me go back to the Kubernetes-ish documentation. So this is a spec called Lifecycle Prestop exec. Okay, so with ports, so what is my container builder going to let me do? Well, except Well, yeah, okay. Let's go look at the container builder from basic. Okay, container builder. Is that our thing, or is this like a thing from somewhere else? Nope. Kubernetes, Scala, container builder. Oh, that's possibly our own thing. Oh no, it's coming from Fabric 8, maybe? Container builder. Oh, I guess this is actually Java code, but that's fine. Okay, so I think this would be with new Lifecycle. Let's go take a look at that. Okay. Lifecycle. Cool. Set pre-stop. Yeah, cool. Resource builder. Rockin'. So that's required ports. Yeah, and var builder. Yeah. So, well, we could just always set a lifecycle that's empty if it's not set. Wait, where's this mapping? Yeah, okay. File lifecycle. Kind of jank. But then we would go ahead and we would say get diff master. What's our configuration property called? Decommissioning. It's in the conf somewhere, right? What the hell is the conf though? Okay, conf. You don't want to do with a lifecycle empty. Yeah, unresolved resource builder. Cool. We're rocking. So let's go do that. Instead, okay. So it's a container port builder. Yeah. So container within core limit, new container. Whoa, okay. So container within core limit is executor limit cores map getter else executor container. Okay. Oh, cool. Someone's calling me from Yonkers, New York. I hope it's not important, and whatever they have can wait. Cool. So we're going to go ahead and val container with okay, lifecycle. So if worker decommissioning is enabled, we go ahead and we write a val lifecycle We actually probably need to do a special version of this. Well, okay. We'll wait a little bit. Or whatever. Okay, I'm gonna finish writing this, and then we'll come back to the part that I think you're gonna have to change. So val lifecycle equals the part that I'm distracted about is I have to make the other thing blocking probably. Oh, there's a lifecycle builder. Lifecycle builder. I don't want Tinker 8. Fabric 8. Oh, actually, there's a lifecycle hook builder that looks like even closer to what we want. Maybe? Is this what I want? No. Maybe. Let's look at the. Lifecycle. I think lifecycle hook builder is what I want today, but we might want something else, except, let's see here. Additional properties, exec with new pocket. And none of those are the hooks that I actually want. We want the other thing, which is under lifecycle builder. Okay. New lifecycle builder, and it's going to take in container. And then edit. Oh wait, no, the lifecycle builder. Oh, sorry, new container builder. No. Well, let's build the lifecycle first. Edit. Pre-stop. Tags. With new pre-stop. Okay. Yeah, with new pre-stop. What's the difference between with pre-stop and with new pre-stop? Okay, yeah, this gives us back a pre-stop object. And I don't have to manually construct it. And then the pre-stop object takes end pre-stop, which gives me back a modifier of type n. What is type n? But I think I need to give it with new exec. And pre-stop dot with new exec. with new exec, and then with, well, there's two instances of with command. That's weird. With command takes a list of, okay, yeah, cool. Yeah. And then we're going to give it, let's go look at that Docker file again. Is it sbin or bin? I think it's sbin. Yeah. Okay. So decommission slave. I kind of want to give it with additional properties. Because we want this to be blocking when it's calling Kubernetes, but possibly not in other things. Because when we return according to the Kubernetes spec, it's going to send the sig term, and so we want to block and actually give it time to finish. So let's go ahead. Let's add two additional properties, or with additional properties, map string object. So fabric 8 with additional properties. Or I wish the Java doc here had more things inside of it. Because with additional properties, I don't know if it's going to set env environments or not. But, okay. Fluent with command set environment variable. Let's take a look. Fuck that. Okay, let's just give it a parameter. Whatever. Oh, cool. No, that's not the hook that I need, but that's cool. The container hook is fine. It's more, I want to pass a parameter to my own script here inside of the lifecycle builder. Yeah, right. So it says it's blocking, right? But so the problem is the decommissioned slave script that we have is non-blocking. And so it's called and then it immediately returns. And that's the right behavior on a lot of systems. For example, if we were doing this on an AWS type system. But in the case of Kubernetes, it's not the behavior we want. We want the decommissioned slave script to block until it's decommissioned or we hit our time limit. And in this case, our time limit defaults to 30 seconds. So we just want to block until the JVM exits, which it's not going to do on its own, and so we'll expire the time limit and get killed. And so even though the Kubernetes thing is blocking, we have to actually have our script block, otherwise it doesn't matter, yeah. / block until exit. Just for now, that's parameter we can we can keep. But that's okay. This is somewhat into the weeds, so it's not super important. Alright. Okay, and then we're going to go ahead and grab our container builder. And, okay, yeah. Then we go ahead and edit Lifecycle, or edit Spec. Can I, let's go look up container builder. Fabricate container builder. Lifecycle, yeah. You are ATM not building a pre-stop. The exec has to be within it. You should do lifecycle builder, then append that to the lifecycle after editing the spec of the container. Yeah. So we make a lifecycle builder, then we build it, and then we append it. Yeah. Oh. Seems like I actually want to do this. Oh yeah, cool. So the question on Twitch is, what am I trying to construct? And the answer is, I'm trying to construct a pre-shutdown, a pre-stop hook. So I think container builder, edit lifecycle with new pre-stop. Oh, and pre-stop. Oh. Is that, yeah, okay, that makes more sense. .end pre-stop.build. So if I call, oh, edit or new, cool. Edit or, there's no edit or new lifecycle. There's edit lifecycle. With new lifecycle, there's no edit or new lifecycle. There's only edit or with new. So if there is no lifecycle, oh, God damn it. These Java docs have no description. Yeah, I'm pretty sure I actually just want to do, because there is no lifecycle here yet. So I think we might want to just do with new lifecycle. I could be wrong though. I'm not super sure. IntelliJ tells me differently. Well, I mean, let's run it and see what happens. Oh, right. It could be that I'm looking at a old version of the Fabricate documentation right now. Cool, that'd be awesome. Oh, then in that case, I should figure out which version of the Fabric 8 stuff we actually have. Kubernetes. Okay, client version, 3.0. Okay. Yeah, that's, okay, yeah. So edit or new lifecycle. Fuck yeah. Okay. Documentation still has like about no information, but that's cool. Thanks. So edit our new lifecycle. That's nested. Oh wait, but I'm gonna wait. Shit, that compiled? Oh, am I not? I don't think I actually compiled the Kubernetes components because I'm slightly concerned as to why that would work. Okay. But yeah, edit or new is, that's definitely what I want. Cool. My battery life is getting a little bit low, so we're going to wrap up in about probably 15 minutes, unless my battery dies first. But I could totally see, hopefully we'll get there. And then while that's happening, let's go look inside of spin decommission slave.sh. And so here's the thing. Okay, yeah. So if we go inside of here, okay, yeah, let's go look at spark-daemon.sh. Where does it find? There's a place where it finds the PID. Yeah, okay. Yeah. Oh, cool. That's actually useful. I should remember this for some of my tests. So we're going to go into decommission slave.sh, and then we're only going to handle blocking in the single instance case. That seems like entirely reasonable. Wait, $PID, but we only want to do this if we're blocking. Or actually we can, let's go take a look. So, okay. Check if dash dash. Oh, command mode error. A command mode editor. No, this is Emacs. If block until exit. For now, we only block on the usage, exit, instance, if there are multiple instances. Instance equals to SM1. It's a bit of a hack. This is done for systems which block on the decommissioning script. This is and on exit issue shut down the entire system, e.g. K8s. Not perfect, but also whatevs. Cool. Our compilation failed, so let's go fix that. Oh god. Yeah. Cool. I misspelled true. So let's go start. Object get is not a package. Okay, conf here is different. Okay, basic executor feature step. Conf here is different, and so we're actually just going to match case true, case false, and we're actually going to, yeah, okay. So conf here is, what's our conf object here? Val conf, okay. Conf, Kubernetes conf. Okay, let's go Kubernetes conf.scala. So we're going to go ahead and go conf dot, I'm going to go ahead and move this over. This down. Okay, cool. And so instead we'll go conf dot worker decommissioning match. Okay. I'll compile again. Okay, value not found, config. So worker decommissioning enabled. Yeah. Git diff master. Okay, this comes inside of internal config package. Oh, fuck. Okay, config. Driver class. Worker decommissioning. Dot config. Cool. Looking good-ish. Okay, it is. Okay, so object worker decommissioning is not a member. Oh, it's not conf. It's so it's now we're referencing the Kubernetes conf. Oh, do you try dynamically typed languages like JavaScript? I've used them. Actually, fairly recently, I did some stuff in Node, just a little bit. I do a lot of work in Python, and I'm more used to Python than I am really JavaScript, and I love Python just fine. It's pretty great. That being said, I mean, the type system here is really clearly helping me a lot. When I'm in systems that are strongly typed, I rely on them a lot more, and so I write software very differently depending on what language I'm in. Okay, cool. It says edit or new lifecycle is not part of IO Fabricate Kubernetes API model container builder. Edit or new lifecycle. Edit or new. Wait, it says, yeah. Maybe I just misspelled something. Typos are the cause of a lot of my problems in life. Oh, my computer is very sad. Oh, cool. Okay, we're getting there. Okay, so now with command .asJava. Okay, and pre-stop. Okay, maybe with new pre-stop, new exec. Okay, my computer will hibernate very soon. We're getting there. We are. Probably not going to finish it today, as y'all can see. And pre-stop. Okay. Oh. So this gives me that, and then I go. Edit or new. So we did with new pre-stop, with new exec. Oh, I need to do end exec, I think. do. Like the indentation here is a little different than the normal Spark one, but I think it makes sense because that's what we did upstream, and it lets us see which, like, every time we do new, it looks like people do another 2 indentations, although the end is at the same. So let's do